So this is going to pick up where our day 1 notes left off, and that actually is on page 2. So this is the second day of 9.7. So we're going to pick up where we left off. So yesterday, just as a reminder, we talked about area. So we did area of a triangle, which was on the first page. We're now going to do what's called Theorem 9.9, or the law of sines, on the second page. And they write it out for you, so they give you this triangle, and they're saying the law of sines is this string of 3 pieces with 2 equal signs in between it, or you can flip everything. So it's 3 sets of fractions, either sine of A over A, sine of B over B, and sine of C over C with equal signs in between them, or you can flip them. And this is a tool that allows you to solve triangles that aren't right triangles. So it is a tool that lets you solve triangles without a 90-degree angle. So it opens up the ability to solve a triangle. And again, solving a triangle means finding all 6 pieces. So all 3 sides and all 3 angles. And up till now, we've just been doing it for 90 degrees. But this lets us do any triangle. And law of cosines we'll do in the part 3 is another way of doing this same thing for a different set of conditions. So we're going to use it and we're going to practice with it. But first, like we did yesterday, I want to show where this thing comes from. So what I'm going to ask you to do down here in the notes section is just redraw that triangle as best you can. So there's our A, there's our B, there's our C, there's little side A, little side B, little side C. And then what I want you to do is put a height in there. So just drop down a dotted line. We'll call that H. It hits at 90 degrees. And what we're going to do then is we're going to actually look at it from each of the angles. So let's start with angle A. So if I look at it, so if I look at this triangle from the side of angle A, and I just look at this left-hand triangle that I created, sine of A would equal H, that's opposite from sine of A, over C. Again, that's just focusing on that left-hand 90-degree triangle. And if I focus then on the right-hand one, if I just look at angle C, then I can say, okay, well, sine of C would be H over A. So in this case, A is the hypotenuse on this right-hand side triangle. So I've got my left-hand side, my right-hand side. Those are 2 90-degree right-angled triangles. And I can use sine of A and sine of C for opposite over hypotenuse. And then what I can do with both of those is on this first one, I can multiply both sides by C. So I'd have C times the sine of A is equal to H. I'm just going to put a little circle around that. And then on the second one, I can multiply both sides by A. So A times the sine of C is equal to H. 2 things that are both equal to H means I can make them equal to each other. So if I have 2 things both equal to H, then I can say, well, by transitive property, C times the sine of A equals A times the sine of C. And again, H just links them together. So now what I'm going to do is I'm going to divide both sides of this thing by A. And on the right-hand side, that's going to cancel out the A's. On the left-hand side, that's going to give me C times the sine of A over A equals sine of C. And then I'm going to do the same thing, except I'm going to divide both sides by C. So it's going to take the sine of C out on the left-hand side, and it's going to make the right-hand side have sine of C over C. So again, divide both sides by A, so I'll write that off to the side. Divide both sides by C, and then you end up with these 2 fractions. And if you were to cross-multiply it, so if you cross-multiplied this thing, you'd get back to the original expression. You'd have C times the sine of A, you'd have A times the sine of C. So this process, this 2-step process, was just undoing cross-multiplication. And then what you've got, if you look at this first equation, you've got sine of A over A and sine of C over C. And we can only link 2 together at a time. So the idea would be that, okay, we can actually then go and shift our perspective on this thing. So if we shift our perspective, and I'll just go up here and use this triangle they gave us. If I now were to draw a height that went right there, not the best height I've ever drawn, but it hits over at 90 degrees, and we'll call that height X. I'm going to call that height x. I can do the same thing, so I can look at it from angle C. So I can say, okay, there's my left-hand triangle. Sine of C would be opposite x over hypotenuse B. So in that case, the hypotenuse would be the side B. And then if I look from angle B, I'm going to look at this right-hand triangle. I'm going to have sine of B is x over C. So opposite is x, hypotenuse is C for that right-hand triangle. So this is the left-hand triangle, this is the right-hand triangle. And I can do the same thing I did before. So I'm going to multiply both sides on this first one by B. So I've got B times the sine of C is x. Oops, sine of C I meant to write. So let's erase that. And make sure I get my right angle, or correct angle in there. So B times the sine of C is x. Put a little circle around that. Then I'll multiply both sides by C on this starred equation, and I've got C times the sine of B is x. Two things both equal to x means I can set them equal to each other. So B times the sine of C is equal to C times the sine of B using transitive property. And then I'm going to do this same process of undoing the cross multiplication by dividing, except here I'm going to divide by B and I'm going to divide by C on both sides. And I'm going to skip a couple of the algebra steps just because they are the same ones we just did. And the outcome is you have this expression. So this expression has sine of C over C in it, sine of B over B. Well, here's that third piece, sine of B over B. And if you have two things, so one thing and two things that have sine of C over C in it, that means sine of A over A and sine of B over B are equal. So you create this string of three things that are equal to each other. And all it is in any triangle, it doesn't have to be a 90 degree. You get sine of A over A equals sine of B over B and sine of C over C. So you can use this law in order to solve triangles. So this is all where it comes from. And again, much like yesterday, what you're really responsible for is how to use it, but it oftentimes helps to see where things come from in order to remember them. So if we jump down to the bottom of our notes template, we're on questions 6, 7, and 8. Today we're going to specifically look at 6 and 7. Those two are using law of sines. And so on this first one, you can see we're given two angles and one side. So if you have two angles and one side, we can use law of sines to get this side right here. And I'm going to call this side A, little lowercase a, because it's across from a capital A. So if we do that and write A over sine of 50, that's going to equal 22 over the sine of 30. And this is just using law of sines. And actually, I'll scroll back up. I'm using the second way of writing it. So I'm using this way right here, where I'm putting the side up on top. And the reason I'm doing that is it means I only need to do one step to get A all by itself. I'm going to multiply both sides by the sine of 50. So I've got 22 over the sine of 30 times the sine of 50. And that's a big expression, but your calculator can handle that expression. So we're going to do pop over to the calculator, and what we're going to do is just type that amount in. So I'm going to do 22, and I'm going to divide that by the sine of 30, and I'm going to hit enter. That's going to give me a value. That's that first value, and then I'm going to take that 44, and I'm going to multiply that by the sine of 50. And hit enter. And that's going to give me an answer of 33.705. And actually, I think we could do this thing just as one string. So let's try it. 22 divided by the sine of 30, close my parentheses, and then I'm going to multiply by the sine of 50. So I think I actually didn't need to do it as two separate computations. Yep, and so we get 33.7 if we're rounding to the nearest tenth, which is what it's asking us to do. So I'll jump back to printout and we'll say A is 33.7. So that's the length of side A. And let's see, now I need to find side C. But to do that using law of sines, I've got to know what this angle measure C is. So first, I went and got side A. Second, I'm going to go get angle C. Well, angle C it's still part of a triangle, and this actually goes way back in time to the beginning of the year for us. Triangles have to add up to 180 degrees for angles. So I've got a 50, I've got a 30, and together those make 80, which means there's only 100 degrees left over. And I'll actually write out what I did there, but I've got 50 plus 30, and then I've got to add angle C to get 180 degrees. So 50 and 30 are 80, plus angle C is 180, and subtract the 80 from both sides, then C would have to be 100 degrees. So there's my angle C. And then that allows me to set up this last law of sines. So this last law of sines, I would do C, little side C, over the sine of 100 equals, and then I can pick either of the other two, either A or B. I'll use B because they started us with the 22 and the sine of 30. So then just like we did before, I'm going to multiply both sides by the sine of 100. So I've got 22 over the sine of 30 times sine of 100. And I'm just going to punch that whole thing into the calculator to get what side C is. So just using law of sines, using the fact that triangle degrees add to 180, that's our second piece. And then our third piece, what we're doing right now, is we're getting little side C. So I'm going to jump to the calculator, and I'm just going to punch in, what would that be? That would be our 22 divided by 22. I better jump back and make sure I'm doing the right keystrokes here. 22 divided by sine of 30 times sine of 100. I was right. So 22 divided by sine of 30 times sine of 100. And hit enter on that. And there we go, 43.3. And we have solved the triangle, 43.3. So that's our little side C. And we've got our side A, side C, angle C. We've got our triangle solved. The only other one we're going to do down here today is question number 7. So question number 7 sets up similarly, except they're only going to give you one angle and two sides, which means the first thing we got to go get is angle B, because it's across from 16. So I'm going to write this one as sine of B over 16 equals, and let's see, let's kind of cut that off so we can see where one starts and one ends. Sine of B over 16 is equal to the sine of 82 over 25. I'm going to multiply both sides by 16, so sine of B is sine of 82 over 25 times 16. And I'm just going to go into the calculator and compute that right-hand side. So sine of 82 times, and then we'll do what, sine of 82, better jump back and make sure I got that punched in right, divided by 25. So let's start again. Sine of 82, close that out, divided by 25 times 16. So times 16, hit enter, and that's going to be 0.63377. We're just going to leave that in there. So sine of B equals that, 0.663. So then I'm going to inverse sine that. And this is what we were doing in the previous lesson, 9.6. So I'm going to inverse sine that decimal. And to 0.633. So that's sine inverse of 0.633. And I'm actually just going to ask that you leave that in there. We're going to hit second sine, and then I'm going to do second, and that little minus sign, if I do that, it's going to take my answer and it's going to put it in the parentheses, and so you don't have to retype it. And then I've got 39.3 degrees. So there we go, 39.3 degrees for angle B. And once you have angle B, you just take 82 plus 39.3 plus angle C is 180. So I would take 82 and 39.3 away from 180. So I'm going to do 180 minus 82 minus 39.3. Hit enter, and I got 58.7. So my angle C is 58.7. And the very last thing I need to do is get side C, and I'll use law of sines for that. So I'm going to go side C over sine of 58.7 equals, and then I'm going to do 16, actually let's go 25 over sine of 82. Multiply both sides by sine of 58.7.